YouTube channel. Today, we are going to learn about the basics of air handling units and its temperature control principle. This is only a short introduction to the AHUs. However, a detailed video about the various BMS controls and sensors related to AHU will be explained in another video. So please subscribe and stay tuned. AHU, air handling unit, is an equipment used to control and circulate air to the building spaces as part of the building HVAC system. AHUs are usually connected to a ventilation ductwork that distributes air to the building spaces. AHUs can be of many types. We will see about the two most commonly used AHU types here. First one is the fresh air handling unit. This type of AHUs takes air from outside, filter and condition it as per the building occupant's desired temperature and provides it to the space. This is called as a 100% fresh air system, as the air being used in this system is purely fresh air from outside. Next is the recirculating air handling unit. This type of AHUs takes air from the building spaces, filter and condition it as per the building occupant's desired temperature and circulates again to the building spaces. This is a 100% recirculating air system, as the air is being recirculated continuously by the AHU. These two types of AHUs can be either used standalone or combined together to provide comfort to the building occupants as required. Let's look into some of the AHU components. AHU itself is a large metal box with the following components. The first component of the AHU is the inlet dampers. This damper acts as a separating device between the air intake duct and the AHU. In order to provide clean and dust-free air to the building occupants, air filtration is always provided in the AHUs. Filtration is typically placed first in the AHU to keep all the downstream components clean. The most commonly used filtration units are: first one is the pre-filter. This is the first stage filtration system that blocks out large particles such as dust, hair, fur, etc. Pre-filter will protect the components from getting damaged by large particles. Next filtration unit is the back filter. This filter helps to remove the finer particles that pre-filter cannot catch. It is also used to remove contamination from the outside air. The next most important component of the AHU is the cooling coil. To provide cooling to the building spaces and to maintain the humidity level in the building, AHUs are provided with heat exchanger coil within the unit. These coils use chilled water from chiller or refrigerant gas to cool the air. Next is the heating coil. This coil is used to heat the air during winter conditions, either with hot water system or with electric heaters. The final component of the AHU is the fan. To push the outside air to the building spaces, fan is provided in the AHU, which pushes the outside air into the building with the help of the ventilation system ductwork. These fans can be either single speed, dual speed, or can be equipped with variable frequency drives to control the speed of the fan. Fan is placed at the end of the AHU. The next component is the outlet dampers. This is similar to the inlet dampers. With the inlet and outlet dampers, AHU can be completely isolated from the ventilation ductwork when it is not in use. In simple terms, AHU takes outside air and pushes it to the building spaces while conditioning the air with required cooling or heating as required by the building occupant. Basic idea of AHU is, when the space temperature goes high, the valve on the return side of the cooling coil will be opened to provide more chilled water or refrigerant gas to the cooling coil. When the hot outside air comes in contact with the heat exchanger coil, which would be low temperature, heat transfer takes place between the hot air and the cooling coil. The hot air molecules absorb moisture from the cooling coil, reducing the air temperature drastically to provide colder air to the building space. This process keeps on repeating till the building space is cooled enough. At some point of time, the building space will be much colder and will require the valve on the cooling coil to be closed to maintain the desired temperature. So the cooling principle is, the cooling coil valve will be either opened or closed to maintain the temperature as required by the building occupant. This activity of maintaining the desired temperature can be automated completely without any physical interaction with the cooling coil valve, using the building automation system or the building management system. Detailed BMS controls of different AHU types with various monitoring and control principles will be explained in the upcoming videos. That's all for today, and thanks a lot for watching this video. If you have any suggestion or comment, please leave it in the comment section. Also, please like this video and subscribe to our YouTube channel.